For this video, we are tasked to find all the left cosets of the subgroup containing the rho sub 0 and mu2 of the group D4, which is represented by this K-list table here. These are actually permutations on S4. We call it D4 because it's dihedral. So we have here the rhos are actually the rotation, the mu's are the reflection on perpendicular bisectors, and the deltas are actually reflections on diagonals. You might want to review a specific video for this on determining all of these permutations on S4. So we are going to solve here or find here all the left cosets. Since our subgroup is indicated already by a set containing rho sub 0 and mu2, let us just call this H because that is how we connect with the idea of cosets with their the index of H and G. And our G here is actually our D4 or S4. Okay. The first thing we can do here is actually determining the number of left cosets, because once we know the number of left cosets for the specific subgroup on D4, then we'll be guided later on when to stop, or do we still need to look for the other types of or the other cosets, because if we lack something, so we need to continue, so on and so forth. Now, the number of left or right cosets, but in this case left cosets, will they be determined by the index of H, index of H in G. Okay, the index of H in G, well, represented by this symbol here. Now we see this means that we are going to take the index of our D sub 4, which is our G in this case, and our H. Now, even if all these permutations are results of S sub 4, our number of elements or the order of D sub 4 is not 4, but it's the number of permutations. We have here 8 permutations, so that's 8 over our index of H, the number of permutations in our H, we have 2. So we are expected to have 4 left cosets, number of left cosets. Okay, this will also be true for the number of right cosets, but since our video or our task here is to only determine the left cosets, so we are expected to come up with 4 left cosets here. And how do we determine that? We could start by looking into the definition of left cosets. It will be generally in this form. You have A, H, where A is an element of D sub 4, and H would be this set here. So all the results, once we operate A to small letter h, as that h are all elements of our subgroup given there. So if we're going to operate all elements of A, which are actually D sub 4, A is element of D sub 4, which is rho sub 1, rho sub 0, 1, 2, 3, mu sub 1, mu sub 2, delta sub 1, delta sub 2, we have 8. We're going to operate all 8 of this to our H. And let's see if we have 4 left cosets, even if we have 8 elements on D sub 4. So let's start, because we'll be using this K-list table, by the way. Okay, let's start with our first element of our D sub 4, which is the rho. If I'm just going to here, A is equal to rho sub 0. This means that if we have this, that's actually rho sub 0 H. Okay, so we're just going to operate them, or some of the references will place here star, but since it's very clear that we simply operate using this case table, we don't need to do that. So let's operate this. In short, we're going to operate our rho sub 0 to all the elements of our H. So the first element is rho sub 0. So rho sub 0 and rho sub 0, the result is their intersection here, this one here. So you'll have here rho sub 0. Okay, and then rho sub 0 operated with mu2. So rho sub 0, you have here mu2. So your result is also mu2. No need to worry about that because our first A element of D sub 4, which is rho sub 0, is our identity element here. That's why we return to the same. Okay, that's the first one. The second left coset is if you're going to use here rho sub 1. Okay, that means, let me rewrite this properly. If our second A is rho sub 1, this means we have rho sub 1 operated to H. So what would be that coset would be? So you have rho sub 1, this one here. Okay, rho sub 1 times the first element rho sub 0, you will have rho sub 1. And then for the second is mu sub 2. So rho sub 1 and mu sub 2 here. That's the intersection. You have delta sub, this one here, delta sub 2. Okay, that's our second left coset. I hope that I'll just simply continue here and hopefully we could see the rest of the Cayley's table. So let's have the third one is if our A is rho sub 2. That would mean we have rho sub 2 and H. And our H, let me rewrite our H here. It's actually the given subgroup rho sub 0 and mu sub 2. Rho sub 0 and mu sub 2. Let's proceed to our Cayley's table. Take note, we have rho sub 2. So rho sub 2 times rho sub 0 is rho sub 2. Rho sub 0, sorry. Rho sub 2. My bad. Okay. And then when rho sub 2 is operated with this mu sub 2 here, the result is mu sub 1. Okay? So that's the result here, mu sub 1. That's our third left coset. Take note earlier, we are sure that we have 4 left cosets. So we are down to our last, but we still have 5 elements. So let's simply continue this one here. If our A is now rho sub 3, that means we are asked for the rho sub 3H, our fourth left coset. So we are now on the column for our row for rho sub 3. Rho sub 3 for times rho sub 0 or operate by 2 rho sub 0. You have this result, rho sub 3. Then rho sub 3 and mu sub 2 here, you will have delta sub 1. So you have here delta sub 1. So already have 4 left cosets. So it should be completed already because we are sure that there are 4 left cosets because of this index of H and G, right? But let's just simply continue. What if our next A is mu sub 1, this one here? So what if our A now is mu sub 1? Hence, we have mu sub 1 H. So if we're going to operate mu sub 1 with rho sub 0, you have mu sub 1, right? So you have here mu sub 1. And the second would be against mu sub 2. So mu sub 1, mu sub 2, you have rho sub 2. So you have here rho sub 2. So this should be our fifth left coset. But why is it that there are only 4? Because I would like you to compare these two. The third left coset and the fifth left coset using rho sub 2 and mu sub 1 respectively. We have the same set actually. The elements are just rearranged. And if we have a situations like this, they are only counted as 1. Okay? Because the left coset using rho sub 2 and mu sub 1 will just result to the same coset here. Okay? The combination or the set containing mu sub 1 or rho sub 2 or vice versa. So this is also true if we are going to continue with mu sub 2 here. That means mu sub 2 H. Sorry, mu sub 2 H. So let's have mu sub 2 here. Mu sub 2 operate by rho sub 0 is mu sub 2. Okay. The coset earlier with mu sub 2 is actually this one here. Let's see if we have the same result. Mu sub 2 and mu sub 2 is rho sub 0. Okay. So you have rho sub 0. See? They are just rearranged. So just still counted as 1. Okay, so we still have 4. If we're going to use the deltas, delta sub 1, that means delta sub 1 H. And if your A is delta sub 2, means delta sub 2 H. Okay, we would see that would also be same as the previous left cosets. Let's start with delta sub 1. Delta sub 1 operate with the first element of our H is delta sub 1. Okay. Delta sub 1. And delta sub 1 to be operated with the second element of our H, mu sub 2, here we have rho sub 3. And this is actually similar to this one here. Okay, we have the mu sub 3 and delta sub 1 just rearranged. And again, for the last one, okay, this would be similar to this one here. That's the remaining coset that was not paired yet. So delta sub 2, and rho sub 0, delta sub 2. Delta sub 2 and mu sub 2 is rho sub 1. So delta sub 2, rho sub 1, we have the same. Delta sub 2 and rho sub 1. So even if we have 8 elements on D sub 4, but those 4 are duplicates of the first 4, we end up with 4 left cosets. So these are the first 4 cosets. They are just the same as the next 4. So we just simply list them. Similar, again, checking, we only have 4 left cosets indicated by this process. So this is your guide, because if you see that there are already 4, you might want to check only 1 or 2, and if you're sure already, then that's already okay. Thank you very much for watching.